Now that we got out of the way this initial set of basic definitions, let's go back to our main concept, which is software verification. We said that software is buggy. And because software is buggy, we need to verify the software as much as we can. But how can we verify software? There are several ways to verify a software system. Among those, we will discuss 4 mainstream approaches. The first one is testing, also called dynamic verification. The second approach is static verification. The third approach is inspections. And finally, we're going to consider a fourth approach, which is formal proofs of correctness. So what I'm going to do next, I'm going to first provide an overview of these approaches and then discuss some of them in more depth. And please note that although we will discuss all 4 approaches, we will spend most of our time on software testing, as software testing is the most popular and most used approach in industry. So let's start with our overview, and in particular with testing. Testing a software system means exercising the system to try to make it fail. More precisely, let's consider a program, its input domain, which is the set of all the possible inputs for the program, and its output domain, which is the set of all the possible corresponding outputs. Given this context, we can define what a test case is. A test case is a pair that consists of an input from the input domain D, and then expected output O from the output domain. And O is the element in the output domain that the correct software will produce when run against I. We can also define the concept of test suite, which is a set of test cases. And we're going to use these 2 concepts of test case and test suite quite a bit in the rest of the lessons. Static verification tries to identify specific classes of problems in the program, such as null pointer dereferences. And unlike testing, what it does is that it does not just consider individual inputs. It instead considers all possible inputs for the program. So it considers, in a sense, all possible executions of the program and all possible behaviors of the program. That's why we say the verification, unlike testing, is complete. The third technique we're going to consider is inspections. And inspections are also called reviews or walkthroughs. And unlike the previous techniques, inspections are a human-intensive activity. More precisely, they are a manual and group activity in which several people from the organization that develop the software look at the code or other artifacts developed during the software production and try to identify defects in these artifacts. And interestingly, inspections have been shown to be quite effective in practice, and that's the reason why they're used quite widely in industry. Finally, the last technique I want to mention is formal proof of correctness. Given a software specification, and actually a formal specification, so a document that formally defines and specifies the behavior, the expected behavior of the program, a formal proof of correctness proves that the program being verified actually implements the program specification. And it does that through a sophisticated mathematical analysis of the specifications and of the code.